Video I'm going to go over hypothesis testing, specifically the binomial distribution. I'm going to show you how you can do it on your calculator. So if we start, for the binomial distribution to be used, these four conditions need to be met. So if we start, given that we have this, calculate these. Okay, so we go to the distribution bit on our calculator. So it matters what symbol this is for which operation we use. So if it's an equals, we use binomial PD, and if it is a crocodile sign, I'll call them more than or less than, we use binomial CD. So since we've got P x equals 2, we'll use for binomial PD, and we choose a variable. So we have x equals 2, we have 9 trials, and the probability is 0.35. And that gives us the probability. So then we do the next one. So we have x equals 6, and we have the same distribution. So P equals 0.04. So now we're going to do P, x is less than or equal to 5. So for this one we're on distribution again. This time we're on binomial CD. And the convention for the calculator is that x is less than or equal to something. So it'll become more important in the next examples. But for this one, we can do 5, and of course we've got the same. So the probability is 0.95 for this one. So as I said, the calculator assumes the left hand side, so as if it was x less than or equal to something. So because we want to find the probability of x that's larger than 5, that's the same as 1 minus the probability that x is less than or equal to 5, right? Because 1 minus the probability of something happening is the probability of something not happening. So if we find that, we can store it in our calculator, and then go back to the main page and do 1 minus our probability, which gives us 0.05. So for our next one, we have the probability that x is bigger than or equal to 4. So for that one, we need to use binomial CD, and we need to calculate the 1 minus the probability that x is less than or equal to 3. Right, because we want x is more than or equal to 4. So if we do 3, 9, 0.35, store it, then go back to the main page, 1 minus our answer, so the probability is 0.39. If we do the same for the last one, so we have the probability that x is more than 2 but less than or equal to 5. So in other words, we can write the probability that x was less than or equal to 5 minus the probability that x was less than or equal to 2, right? Because it doesn't include 2 here. So if we find them, so for this one, because they're both cumulative, we can do 1, and we can do list because we want to find 2 probabilities. So we have x is less than or equal to 5, and x is less than or equal to 2. And the probability can be found if we submit these numbers in. So we have 9 and 0.35, and then it gives us our 2 probabilities. So we have 0.9464 minus 0.3372. which if we minus 0.9464 minus 0.3372, that gives us 0.6092. So if we move on to another example, a fair coin is tossed 10 times. So already we know, because it's fair, we can use the binomial distribution. Because a coin only has success or failure, or heads and tails, the trials are independent of each other because we assume that fair means each side has an equal chance. So we have 10 trials, and we know a coin only has 2 sides. So what's the probability it shows tails at least 6 times? So we want P, X is bigger or equal to 6, right? Which equals 1 minus P, X is less than or equal to 5, which is what we can calculate. So if we go back on distribution, and then we go back on cumulative binomial, and variable. So we have 5, 10, 0.5. We store that answer. We minus our answer from 1, so we get 0.38 to 2 decimal places. So if we move on to the next one, the probability of hitting a ball with a bat is 0.6. Okay, so if we write our binomial distribution, the probability of hitting a ball with a bat is 0.6. We have it there. 20 balls are thrown, so we know that's there. 20 trials. Assume the attendant. Find the probability that x equals 10. So if we go on to distribution, binomial PD, variable x equals 10, n equals 20, and p equals 0.6. Probability is 0.12. This one, find the probability that x is bigger than or equal to 15. So we want to go on distribution, binomial CD, variable. So to do this, we do 1 minus the probability that x is less than or equal to 14. So we have this value. If we store it and do 1 minus our value, we get 0.13. So for this next one, we have the probability that x is less than or equal to 8. So again, we go on distribution, binomial CD, variable, less than or equal to 8. So our probability is 0.06. So for this last one, go on distribution, binomial PD because it's equal, variable equals to 20. So that probability equals 3.66 times 10 to the negative 5. So a very small number. So if we do some more examples, so some more information on it is a hypothesis test provides an answer to show if a sample provides significant evidence that a population parameter has changed from a previous assumed value. So the significance level used in calculations is 5%, but in practice could be any percentage. So the critical value at 5% is 1.96, which is what we'll be using to compare our values with. So the null hypothesis and the alternative hypothesis are covered, and with 1 and 2 tail tests. So if we do an example here, the 2011 census showed that 68% of 16 to 19-year-olds in one city attended high school. In 2013, a sample showed 60 teenagers were surveyed, and it was found that 46 of them attended high school. Is there any evidence that the proportion of teenagers in this age cohort attending high school has increased? So we have a binomial distribution, and we know that the number of students was 60 and the probability was 68. No, because that's what we got from the census. However, we want to find out the probability that x is above 46. Because of our null hypothesis that the probability equals 68, and our alternative hypothesis that the probability is larger than 68, because 46 over 60 is larger than 68%. So we want to test if the proportion of teenagers going to high school has increased. So if we test this value, we get if we test it against 45, because it's x is less than or equal to 45, so if we store that answer, we get 0.094. So if we minus that, we got that from here, 0.094. So we're going to compare 0.094 with 0.05 because we're testing at 5% significance level. So because 0.094 is bigger than 0.05, that means we reject the alternate hypothesis and we stay with the null hypothesis. So we reject